In this presentation, I plan to talk about our paper, A Design Space Exploration of Worlds in Miniature. In our work, we performed a survey of existing world in miniature systems. From this survey, we contribute a design space that can be used to help describe and generate new worlds in miniature. In this video, I will first describe what a world in miniature is. Next, I will discuss the process we use to create our design space. Following, I'll introduce the design dimensions, and finally, I'll walk through a practical exercise of applying the design dimensions to a problem. So first, before I get into the details of the paper, what is a world in miniature? A world in miniature is a scale replica of an environment that is linked to the original space by interaction or virtual feedback. It is an interactive world within a world. To put a picture to that concept, here's an example of a world in miniature. In this image, we see a scale replica of a virtual cityscape, alongside its corresponding virtual world. In this example, the world in miniature is being used as a tool for wayfinding. By placing a push pin in the replica, it is also placed in the environment to create a direct, understandable, and controllable link between the two spaces. So, what makes these an interesting topic to survey? As mixed reality systems become more commonplace, there is opportunity for worlds in miniature to leave the research lab and enter the consumer space, and our survey will help designers understand the diversity of these systems, while our design space should aid in their creation. Worlds in miniature can have a wide variety of uses. We observed 5 major use cases in the works we surveyed. They can be used for wayfinding, as you saw in that last example. They can serve as a tool for collaboration around a shared space. They are a close equivalent to an overview and detail system when used for visualization. They can be used to navigate a virtual environment, such as by allowing the viewer to teleport with it, and they can be used as a control space. For example, they can serve as a 3D dashboard of building controls. That definition in mind, we collected papers about worlds in miniature, 25 in total, showcasing a wide variety of themes and applications. Based on that set, we reduced them to just the details that described the form of the replica. This reduced set of codes would eventually become our design space. So what is in that design space? Our final design space dimensions are size and scope, abstraction, geometry, reference frame, links, multiples, and virtuality. Due to time, I will just go into more detail on 2 of these dimensions. The first I'll detail is abstraction, which describes how the replica has been transformed compared to the space it represents. We noticed a wide spectrum of styles of abstraction in the papers we surveyed, and the images here are a sample from our paper that show these styles. In examples like A, B, and C, the environment is recreated as a direct copy. In examples like D and E, pieces of the environment are simplified and emphasized. And examples like F and G, the replica is reduced to just broad areas or a wireframe. The other dimension I'll discuss is links. These are features that directly link the scale replica with its environment. There are a wide variety of potential links, more than we observed in our sample. 2 examples that we did observe, though, are C, God hands, which show the position of the viewer's hand on the replica in the environment, and D, leader lines, which directly connect the replica and the environment. To help better understand these dimensions and how they may be used, I will apply a few of them to a simple design problem. For this example application, I will envision a world in miniature system where the scale replica used is an architect's model. For those unfamiliar, architects will commonly make physical models of buildings that they are designing to get a better understanding of the final product. With a model in mind as a constraint, some of our dimensions will just be descriptions based on that model. The first of those is easy. A replica differs from its environment because it is a physical copy of the building, and our scope is just that, a building. While these models vary in size, this particular example is 30 by 30 centimeters, so we'll use that size. From here, we have some choices. In this case, I'm going to just emphasize links. So how do we connect this architect's model to the virtual environment or real environment that it shows? One way we can connect them is via highlighting. In this mock-up, a physical architect's model is used as a replica for a building under construction. The connection between them is formed through highlighting. By pointing at a piece of the replica, that same area is highlighted on the building. And with that, this has been a summary of the paper. Thank you for listening.